Did you know that SoundCheck can calculate the overall perceived loudness level using a Zwicker Loudness post-processing step? Instead of just measuring the absolute sound pressure level in dB SPL relative to 20 micropascals, the Zwicker Loudness algorithm takes into account how humans hear sound level using the PEAQ international standard. This is an ITU-developed standardized algorithm for objectively measuring perceived audio quality as subjects would in a listening test. The input to this post-processing step must be a spectrum of a complex signal in pascals or dBSPL. We can easily capture this in SoundCheck using either an FFT or RTA broadband measurement using a calibrated reference mic signal path. To simulate the nonlinearity of the ear, the Zwicker Loudness algorithm then filters these frequencies into auditory bands according to the BARC scale. A frequency scale with equal distances correspond with perception. Once the spectrum is plotted on a BARC scale, a frequency weighting is applied that correlates to human hearing. Finally, a level compression is applied and the loudness is output in fons and sones. The loudness spectrum can optionally be shown with the x-axis either in Hertz or BARC. Knowing the actual perceived loudness of a signal is extremely important for certain applications. For example, listeners that are trying to subjectively compare different headphones will be biased towards the louder one. If I want users to subjectively compare two different headphones, I need to make sure they're played back at the same level to avoid this bias. Looking at the 1 kHz sensitivity of each headphone doesn't take into account the difference in frequency response across the two devices. Often A-weighting is used to correlate measurements to human hearing, but a simple A-weighting curve makes a lot of assumptions, such as what level of playback is going to be used. Zwicker Loudness gives us a much more accurate perceived loudness and enables us to precisely match the loudness in fons between the two devices regardless of level. Zwicker Loudness is also widely used in communication testing for measuring loudness of both speech transmission and ringtones. Check out our website to learn more.